Hello everyone. It's a pleasure meeting you all in mathematics class. Today let me explain how this Fourier problem is done. See, this is the problem that is given here. Here you are given what is a Fourier series? Fourier series is nothing but expressing a given function in terms of sine and cosine. So you see that here x squared is a function given to you, and that you must be able to express it as a trigonometric series in the interval axis lying between minus pi and plus pi. This is the problem. See, let f of x be equal to x squared, and this x lies between minus pi to plus pi. Minus pi to plus pi. The Fourier series is given by f of x is equal to a naught by 2 plus sigma of 1 to infinity of an cos nx plus sigma of 1 to infinity of bn sin nx. Call this as 1. Now these are all called the coefficients, Fourier coefficients. A naught, an and bn are called Fourier coefficients. Fourier coefficients, and a naught is given by 1 by pi. It is minus pi to plus pi f of x dx. An is equal to 1 by pi minus pi to plus pi f of x cos nx dx. Bn is equal to 1 by pi minus pi to plus pi f of x sin nx dx. So this is what we should find. You see that here a naught value, see this is the Fourier series, and in this Fourier series a naught value is this, and an value is this, and bn values, they are called the Fourier coefficients. Now it is our job to find the values of this. Substitute in 1, you get the answer. Find the value of this, because you know f of x is given to you as x squared, and you do the integration. Here you must be able to, you must know how to do the integration. You do that integration, substitute the values here, you have got the answer. Now, but if you are going to start finding the values, sometimes it may be very laborious, very hard task to evaluate every integral. So under certain conditions, you may try to find out whether all coefficients got to be determined, or we can just overcome the difficulty by not finding the values of the certain Fourier coefficients. What I mean is that depending on whether x is where x is defined, we can conclude whether a naught, an, bn will exist or not. That is, whether a naught, an, bn will have values in the interval x defined in that interval. X defined in the interval for the given function. For the given function f of x is equal to x squared, which coefficient, Fourier coefficient, will remain and which will not remain, we can determine. If x is defined in the interval minus pi to plus pi. What you just see how I am going to do this. See, you take this as 2 and this as 1. Now I will tell you what is this. See, what is your given, your f of x is equal to what? X squared. I take it for granted because I have already done a video on this Fourier series. So you can just go through that and you will find my full explanation on Fourier series. And this is a problem that I have taken. So without giving much of explanation to Fourier series, I am straight away getting into the problem. Okay. Now you just say that if f of x is equal to x squared is given to you. So f of minus x will be equal to minus x whole square, which is equal to x squared, which is equal to f of x. That is, f of x is equal to f of minus x, which implies that f of x is an even function. Therefore, integral of minus a to plus a f of x dx will be equal to 2 times of 0 to a of f of x dx. And if f of x is odd, that is f of x is f of minus x is equal to minus f of x, then integral of minus a to plus a f of x dx is equal to 0. So these two things you must know. If f of x happens to be an even function, then minus a to plus a of f of x dx will be equal to twice that integral of from 0 to a. But if it is an odd function, you see that is f of minus x is not equal to f of x, in which case the integral becomes 0. So this is 0. Okay. Now keeping this in mind, you see that this f of x is equal to x squared is an even function, and hence we can apply this result. Okay. Therefore, I write it here. Therefore, since it is even, f of x is even, f of x is even implies, see, we have got this. See, bn will not exist. See, bn will be equal to 0. See, the reason for this I will tell you. What is bn? Bn will be equal to your minus a to plus a 1 by pi into minus pi to plus pi. This is f of x sine nx dx. This f of x is even. This is odd. So odd into even will be your odd. Therefore, this will become 0. Okay? Because of that, it becomes 0. Whereas an will not. An will exist and a naught will also exist. So we have to find the value of a naught and an. Now, let us start finding the value of a naught and an. What is an? I'll write one by one. See? What is your a naught? A naught is equal to 1 by pi minus pi to plus pi of f of x dx. That is 1 by pi minus pi to plus pi x squared dx. So this is equal to, it is yes. So this is 2 by pi 0 to pi x squared dx, that is 2 by pi x cubed by 3 going from 0 to pi, and this is 2 by pi into pi cubed by 3, that is equal to 2 pi square by 3. So a naught, we have got the value of a naught was, a naught is equal to 2 pi squared by 3. So this is what we have got. Now let us find what is our an. What is our an now? An is 1 by pi minus pi to plus pi x squared into cos nx dx. So this is equal to 2 by 0 to pi, 2 by pi 0 to 2 pi x squared into cos nx dx. Now let us use Bernoulli's method of integration. So this is nothing but 2 by pi 0 to pi x squared into d of sin nx divided by n. So now if we differentiate, you will get this. So it is, if you differentiate, this is called, if you take the differential of this is cos nx into dx. Now you see that applying Bernoulli's method of integration, you will find that 2 by pi, and this is x squared into sin nx by n minus, differentiate this x squared 2x into integrate this, integration of sin nx is minus cos nx, already one n is there, n squared, plus differentiate with respect to x 2 into minus 1 into 1 by n squared into integration of cos nx is sin nx divided by n. Everything has to be taken to by the limit 0 to pi. So this is equal to 2 by pi into, see, if it is sine, try to understand that sin n pi is equal to 0 for n, for all values of 1, for all n. For all n, whether it is positive, this thing, odd or even number, the sin n pi will be equal to 0, whereas cos n pi, see, it depends on when n is even, it is 1, when n is n even, and is equal to minus 1 n odd. So if n is odd, cos n pi is equal to minus 1, n is equal to, n pi is equal to 1 if n is even, see, n even. And cos n pi is equal to 1 for n is equal to 0. So for n is equal to 0 and odd values, cos n pi is equal to 1. Whereas for even values and n is equal to 0, it is 1. For odd values, it is minus 1. Whereas for cos sin n pi, whether n is odd number or even number, it will be 0 only. Okay. Now, have that in your mind, because these are all some basic ideas that you must have. So this value will be 0 and this value will be 0, and we will apply only the limit for this. Take this minus sign outside, so this will be, say I'll write it here, it is plus 2 by n squared, you can see minus and minus is plus, 2 divided by n squared, it is cos nx, it is 0 to pi. So this already 2 by pi is there. So this will be 4 by pi squared n and 4 by n squared pi, 4 by, and if you apply the limit pi, this is pi. This is pi into cos n pi. When you apply the second limit, x is equal to 0, the whole thing will become 0. So this is what you'll have. Cos n pi, I told you, cos n pi is, see, cos n pi, see, I'll write here, cos n pi is equal to minus 1 to the power of n. That is, when n even, it is equal to 1, n odd, it is equal to minus 1. So I will put when n is equal to 1, it is minus 1. When it is 3, it is minus 1. When it is 5, it is minus 1. Whereas for 2, 4, 6 even numbers, it is. So this cos n pi is minus 1 to the power of n. So it is 4 by n squared pi into minus 1 to the power of n into pi. So this pi and 5 will go off, giving you minus 1 to the power of n into 4 by n squared. So this is, so what is it you are having here? So your an is equal to minus 1 to the power of n into 4 divided by n squared. N squared. Now we will substitute in 1. Substituting in 1 we get we will substitute this in 1 and we will get the answer. The first one will be gone. That is, substituting in 1, we get we get, see, f of x is equal to x squared is equal to a naught by 2. What is a naught by 2? 2 pi squared by 3 divided by 2 plus, see, this is your, yes, an, bn is 0. bn. So this is plus, it is minus 1 to the power of, I'll write it here, it is 1 to infinity of minus 1 to the power of n into 4 divided by n square into cos nx. So this is equal to, so these two and these two will go off, giving you pi squared by 3 plus, take this 4 outside. You cannot take this n because n is the running variable here. So it is 4, 1 to infinity. It is minus 1 to the power of n divided by n squared into cos nx. This is your, and you see that this and this. See, we have got the answer. Now you see that I am able to prove that x squared is equal to the trigonometric series or the Fourier series given there is. Let us take this. This will prove this. Okay, now you are having this result. F of x is equal to x squared. Now you take x. I will let x be equal to your, take x is equal to pi. That means I try to find the value of this function at the point x is equal to pi. Equal to pi, you get pi squared is equal to pi squared by 3 plus it is 4 into 1 to infinity of minus 1 to the power of n divided by n squared into cos, there's a, okay, whatever it is cos n pi, cos, it is cos x is equal to pi means cos n pi. So this is nothing but what? So this is what you will get as, it is pi squared by 3 plus 4 into, again it is 1 to infinity of minus 1 to the power of n into minus 1 to the power of n divided by n squared. That is equal to pi squared by 3 plus 4 into, it is 1 to infinity of minus 1 to the power of 2n divided by n squared. But this is minus 1 to the power of 2 means minus 1 to the power of minus 1 whole square into n. Therefore, this will become positive. So, answer is this. So, this will be pi squared by 3 plus 4 into, it is sigma of 1 to infinity of minus, it becomes plus, it is 1 to the power of n divided by n squared. Because minus 1 whole square is 1. Then minus 1 to the power of then it is 1. Therefore, 1 to the power of n. So, what is that you get? You bring it to the other side. 3 pi, this is 2 pi squared by 3 is equal to, it is 4 into sigma of 1 to infinity into 1 by n squared, which implies, so you cancel this on both sides, it is pi squared by 6 is equal to sigma of 1 to infinity of 1 by n squared. So I am able to get this result. So this pi squared by 6 I am able to get. I am able to prove the first result. Then I will take x is equal to 0 at the point x is equal to 0. You will take what happens if x is equal to, at the point x is equal to 0, what is happening? See, put x is equal to 0. When you put x is equal to 0, what is that you get? X is equal to 0. It is pi squared by 3. It is pi squared by 3 plus 4. It is 1 to infinity of, it is minus 1 to the power of n divided by n squared into cos 0. But cos 0 is 1. Therefore, we get, it is 0 is equal to pi squared by 3 plus 4 into within brackets put n is equal to 1 minus 1 by 1 squared plus cos 0 is 1 plus 1 by 2 squared minus 1 by 3 squared plus dot dot dot, it goes up to infinity. That is minus pi squared by 3 is equal to minus 4. I am taking this minus sign outside. 1 by 1 squared minus 1 by 2 squared plus 1 by 3 squared minus 1 by 4 squared plus dot 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 up to infinity. Now you see that minus on both sides, make it as plus. So this implies 1 by 1 squared plus 1 by 2 squared plus 1 by 3 squared dot 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 up to infinity is pi squared divided by 12. See, bring this 4 here. So I am able to get this result. See, this I have got. I am able to get this result. In the first case, I got this result. Now in the second case, I am able to prove that this 1 by 1 square plus 1 by 2 square plus 1 by 3 square up to infinity is equal to pi squared by 12. Now we have got these two results. What I do is, see, we want to get this result. We want to get this result. See, I am going to get the third. I am going to solve the third one. What I do here is, see, you call this as 1, call this as 2. Now you take, we want 1 square plus 3 square. So you just 1 plus 2. Add 1 and 2. So these two will be added. These two will get cancelled. So it is 1 by 1 square. So you will get 2 times of that. 2 by 1 square plus this 1 by 2 square minus 1 by 2 square, they will get cancelled. Get you 3 square plus 1 by 5 square plus 1 by 7 square plus dot 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 infinity is equal to add this pi squared by 6 plus pi squared by 12, that is equal to 2 pi squared by 12 plus pi squared by 12, that is equal to 3 pi squared by 12, that is equal to pi squared by 4. So this is what we get here. See, it is equal to, we get this. So we will get this. So 2 into this will be nothing but, see, that is, this implies 1 by 2 square, 1 square, 1 square plus 1 by 3 square plus 1 by 5 square plus dot 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 infinity is equal to pi squared by 8. But this is nothing but, I can write this as 1 to infinity of 1 by 2n minus 1 whole square is equal to pi squared by 8. Because you put n is equal to 1 here, put n is equal to 1, you will get 2 minus 1 is, you will get the first term. Put n is equal to 2, you will get the second term. Put n is equal to 3, you will get the third term. Put n is, so instead of writing this series fully, I can write it as sigma of 1 to infinity of 1 by 2n minus 1 whole square is equal to pi squared by, this is pi squared by 8. See, this is pi squared. So this is equal to, I have not written here, this is equal to your pi squared by 8. So this is how we do the problem, and yes. So I will just repeat this. I have proved this. For this, you put x is equal to pi here. If you put x is equal to pi and do the simplification, you will get this. And for the second one, you put x is equal to 0, you will get the second result. Do all the simplification, you will get I have explained everything. So put x is equal to 0, you will get the second result. To get the third result, you add the 1 and 2. What will happen is minus 1 by 2 square plus 1 by 2 square. Minus 1 by 2 to the power of 4 square plus 1 by 4 to the power of 4 square. See, these two will cancel. Here you will have that, here 1 by 3 square plus 1 by 4 square. Here minus 1, this will be here. These two will get cancelled. So leaving you with what? 2 into 1 by 1 square plus 1 by 3 square plus 1 by 5 square up to infinity. This is equal to, you see that this is your, what you are having is here pi squared, see, pi squared by 6 plus pi squared by 4. I have shown you that how you are getting pi squared by 4. Therefore, 2 into this will be equal to pi square by 4. Therefore, the value of this is equal to pi square. So, the value of this is equal to your pi square by 8. So, I am able to get the third result. So, you see that, therefore, I take here in this case x is equal to pi. Here in this case x is equal to 0. You get the results, add them, you will get the answer. Okay. I will do more problems to make you understand better and how to